heavy equipments, so etc. So by definition, how can we define it? So a pulley is a simple machine which helps us to apply the effort less than the load, and it changes the direction of effort at a convenient direction to lift up the load. Understood, friends? Okay. Now just assume that this is a pulley. Just assume, but don't consider this as for, okay. Just leave it, okay? So a pulley, it will be having it is a small circular disc. It will be made up of either wood or metal. So it can turn in all the directions, and it will be having a small axle passing through its center. Okay. So this pulley is used by just tying a small string or a rope in that disc. So how does it work? So the disc, it will be having small grooves. So grooves means, so here can you just see? So like this, you will be having one groove on its rim. So through that, the string or the rope can pass around. So the end of the axle that is passing through the center is fixed to a frame. It's called as the block. So the block is then fixed with the help of a support. So the support in the you may have seen this. It will be like this. Here one small hook will be there. Here the pulley will be there. Here a small rope will be there. Here the bucket will go inside. Have you seen? So that's what we mean. Understood, friends? So in order to lift a load, so the pulley, the load will be tied to one end of the rope of the pulley, and the effort will be applied on the other end of the pulley by pushing it. And the next one is the mechanical advantage. So the mechanical advantage of a pulley, of an ideal pulley, you need to keep that in mind. Ideal pulley is equal to 1. We know that, right? But due to the presence of friction, the mechanical advantage of a pulley is less than 1. So even if the mechanical advantage is less than 1 or equal to 1, why do we prefer it? What's the use of it? The main thing is, so if you need to just take a heavy equipment from the ground, you need to apply a lot of effort and you want to just take it off. But with the help of a pulley, you don't need to apply the effort upwards. You need to apply the effort downwards. Can you understand? So just imagine there's a bell, okay? And that pulley, and there's a pulley, and there's a bucket of water inside the bell. So you don't need to lift it. Just apply the effort in a downward direction on the rope, and the load will be coming upwards. You can also use your own weight by tying yourself on one end of the rope, and so that the bucket of water will come up. Understood, friends? Okay, now we learned about the pulley. The next is wheel and axle. So it is also a simple machine with a wheel and an axle. So a wheel is a circular object which can turn around in its own axis. So that axle, so here we'll use this, okay? So the axle, so this is a wheel, right? So in a wheel and axle, there will be either one wheel. So here there is only one wheel and there is an axle at the center. This is called as the axle. And in the previous video I told you about nut, right? So this is the nut. Okay, that's the nut, okay? So here there is an axle which is passing through its center, and here is only one wheel. But in some wheel and axle, there will be two wheels, and here no axle will be there. Here one axle will be there. Understood, friends? So in a wheel and axle, the wheels will be of varying diameters, so that they can prefer to linear motions. So in this wheel and axle, so this one is a bit bigger than this. So the bigger wheel, here this wheel, the bigger wheel, we apply the effort on it, while the smaller wheel, which is called the axle, we apply the load on it. Understood, friends? So in a wheel and axle, both the wheels won't be of the same diameters. One will be bigger, one will be smaller. Understood, friends? So here the mechanical advantage will be always less than 1, because the effort we already learned in the trolley. So we don't need to push or move it by applying more effort, only less effort. So the mechanical advantage is always less than 1. So the next one is inclined plane. So for inclined plane, let's consider this. So an inclined plane is a slanting wooden plank or a sloping surface. So these vertical height, that is CB. This is A. No, this is A B. No, the A B C. Understood, friends? A B C. I think so, but I'm not sure. Okay. So the distance of this slope, that's the A and B, must be greater than the distance, that is C, and the vertical height of the CB. Understood, friends? So this is called as the principle of an inclined plane. So in an inclined plane, the effort that's required to move and load up is always less than 1. So hence the mechanical advantage is less than 1. So where are these types of inclined planes are used? So inclined planes are mostly used by coolies. So in order to push a heavy drum, just imagine this is a heavy drum. So instead of just lifting it and keeping it here, the coolies, they do a clever trick. That is, they will have something like this, something like an inclined plane. Just imagine that this is an inclined plane, and they will just roll it and they will keep here. Understood, friends? So this small slanting surface is called as the inclined plane. Okay. So the inclined plane is also used in some types of shopping malls. So you may have seen ramps, right? So these types of ramps are used for many purposes. So there are 3 purposes. Okay. First purposes. So some people needed to keep their scooters, bicycles, motorcycles inside a building. So it's very difficult to just lift the scooty and keep it inside. Instead, with the help of a ram, they can just push it to the ram and they can keep it inside the building, right? The second use is, so it is used in hospitals. So because of this, the nurses they feel very easy to go up with the help of the patients in the wheelchairs, right? So the wheelchairs are also called as stretchers. Okay, stretchers. It is also used in big shopping malls. So in order to push heavy equipments from one floor to another floor, we can't just use a crane. Sometimes it's difficult, sometimes it's convenient, but we can't go make a crane go into a huge building, right? So for that we use either staircase or ramp. So with the help of that, the heavy equipments can be taken to the other floor. Understood, friends? So these are the uses of the inclined plane. So the next is about a wedge. So a wedge is made up of 2 inclined planes. I'll show you this, okay? So this is a knife, right? It's made up of 2 inclined planes. So here is one inclined plane, here is one inclined plane, right? So a wedge, it has a sharp edge and it's made up of 2 inclined planes putting together. So a heavy wedge can be easily put into a piece of log, can be split into 2 pieces. So some of the examples of those types of wedges are iron nail, knife, needle, then plow, axe, saw, etc. So these are some of the examples of wedge. Okay. The next is about the screw. So this is a screw. Understood, friends? So what do you think a small difference between this iron nail and the screw? So a screw is nothing but a small inclined plane. So this is an inclined plane, this is an inclined plane, right? So it's an inclined plane, but one thing is different, that it has spiral grooves. A screw is made from a straight metal rod by cutting it into spiral grooves. So these spiral grooves of the screw are called as the threads of the screw. So the tip of the screw is narrow and very pointed, and it is called, the end of the screw is very narrow and pointed, and it is called the tip of the screw. So the other end of the screw is flat, and that is called the head of the screw. So there's a narrow slit. Can you see here? Impression, small impressions there. Narrow slit which ensures that the screw can be easily driven with the help of a screwdriver. So yes, this is flat. I can't just insert the screwdriver inside it. So as there is a narrow slit in it, so that it can be easily driven with the help of the screwdriver. And So I'm not gonna do it. I already have done it. Okay. So here can you see some small holes? So these I have done with the help by hammering this iron nail into this. Okay. By doing like this, I made it. But here one impression can you see? I have made it with the help of a screw. It is because the screw did not go inside. I used all my effort, but it did not go inside. What's the reason? Because of the threads. The threads ensure that the screw can be only ensure to go inside this small wooden rod with the help of the screwdriver. Understood, friends? So that's all we need to know about all the simple machines. The main thing is, so you'll be thinking, these machines can be very, very easy. I shall be very lazy and I shall sit in my easy chair and I shall be watching TV. But if you just leave this any machine down and go, use it and put it down. Use it and put it down. What use? Nothing. Money only waste. Energy only waste. Understood, friends? So that's what we're going to learn about this care of machine. So we use many machines, many simple machines in our daily life. So we use them for our convenience. So we need to use them by following the 4 precautions. So the first precaution is the machine must be cleaned and it must be free of dust. If some parts of the machine, so this is a machine, right? It's made of iron. Can you see this part is fully rusted? This is a machine. It's rusted. So some parts of the machine it will be made up of iron. It can be rusted. This is made up of iron. Why did it not rust? It's painted. So in order to prevent that, we can just paint the iron surface. The third is friction causes wear and tear between the moving parts of a machine. So in order to prevent that, we can use the process that's lubrication. So we can use the lubricant, which is oil and grease, and we can apply it in these types of areas. Hence, the friction can be reduced or prevented. Understood, friends? So in today's class, we learned about great adventure of the simple machines. So we learned about work and energy. We learned about the machines. All these chapters, all these lessons, which are principles, efficiency, ideal machine, actual machine functions. Then mechanical advantage. Then we learned about the second machine, the first simple machine, the lever. We learned about their principal classes, then the distinction between the different classes of levers. Then we learned about the second, that's pulley. Then we learned about the mechanical advantage, then wheel and axle, inclined plane, bush and screw, and then we learned about the care of machines. So thank you, friends. Hope you see you in the next class. Bye bye.